I welcome you all for this presentation. In this presentation, we are going to discuss Diffie-Hellman key exchange multi-party computation. Especially, we are going to solve a problem based on Diffie-Hellman key exchange multi-party computation. So, before solving the problem, let us discuss the steps involved in Diffie-Hellman multi-party computation. Already, we have learned how to exchange the key between two users. And we solved one problem also. So now we are going to learn how to exchange the key between n users. Here n equal to, we are considering n equal to 3 users for simplicity purpose. If the n is any number 4, 5, 6 means also the same procedure only we have to follow. So the first step involved is the parties has to agree on the algorithm parameters P and G. Already in two-party computation we have seen what is P and G. P is a prime number and G is a primitive root of that prime number P. So this is very important. Always we have to choose a prime number and primitive root of that prime number only. Then the parties generate their private keys. So here we are having only 3 parties. So 3 private keys are there. So Alice's private key is A, Bob's private key is B, and Carol's private key is C. So here while choosing the private key, we have to use one condition. That means always the private key must be less than G. What is G? The primitive root of the prime number P. So this condition always we have to follow while choosing the private key values. Then what happens? We are having only 3 users, that is Alice, then Bob and Carol. So how the values are exchanged, and finally how all the members are having that shared secret session key, that only we are going to discuss now. From third step onwards, exchange happens. So the Alice computes G power A mod P. We are aware that what is G? It is a primitive root of that prime number, because everyone agrees on that value P and G. So everyone knows that G value, but Alice only knows the private key A. So Alice is computing G power A mod P and sending that value to Bob. Then what Bob is doing is, Bob is having the value now G power A mod P value is known to Bob now. So with this value, Bob is having the private key B. So what Bob is doing is, this G power A in this power G power A into B mod P, Bob is computing and sending that value to Carol. Then what Carol is doing is, now Carol is having the value G power A B mod P. So now Carol is having the her own private key. So the private key C alone is known. Then the parameters, the common parameters are known to Carol. So with that private key, what Carol is computing is G power A B C mod P. And now this becomes the shared secret key. So everyone has to compute this particular value only. But how they are computing? That is the step involved in this Diffie-Hellman multi-party computation. So now Carol is having G power ABC mod P. So Carol can use it, this value as the secret session key. Then what Bob is doing is, so now one cycle over, that means Alice sent to Bob and Bob sent to Carol, and finally Carol computed the shared secret key. Now Bob is computing, the same procedure is followed by Bob to Carol, then Carol to Alice. See here, Alice to Bob, Bob to Carol, then Bob to Carol and Carol to Alice. Then Carol to Alice, then Alice to Bob. Finally, everyone is having that value G power A, B, C mod P. That value everyone is having. So, always you have to keep it in mind. If some problem is asked in this multi-party computation, means the value must be same only. Suppose if you are getting different value, you have to check. The answer is wrong. Likewise, you have to come to the conclusion, because the main objective here is we are sharing this shared secret key. So everyone has to agree upon one common key. For that, how computation happens, that only we are solving here. So if you are getting different values, means the answer is wrong only. So always you have to keep it in mind. But don't do only computing the first step and then don't tell that this is the shared secret key having everyone is having. Likewise, don't tell. So you have to compute all these steps. So all these steps you have to follow, And finally, Alice is having the shared secret key, Bob is having the shared secret key, and Carol is having the shared secret key. This way you have to compute. So these are the steps involved in multi-party computation. Let us solve a problem based on Diffie-Hellman multi-party computation. So one question is given like this. So here for simplicity only I have taken the same users, Alice, Bob and Carol, are part of a group chat application where they want to establish a shared secret key for secure communication using Diffie-Hellman key exchange algorithm. They agree to use the prime number p equal to 17. So what are the things given? What are the values given? So given are p equal to 17, it is a prime number, and one more common parameter we need, right? That is the primitive root g equal to 3 it is given. So sometimes in the question the primitive root may not be given and you are asked to choose one primitive root. So something like this, because you already know how to compute the primitive root for a prime number, right? So choose g as the first primitive root of 17, or g as the third primitive root of 17, or g as the last primitive root of 17. Likewise, some extra twist may be also given. But in this question it is given, so we are using it. Suppose it is given like that, means you are asked to compute the g value and take among that g values, take one of the g values, means you must be in a position to do. So everyone has to know how to compute the primitive root of the prime number. So now no need. So as such we are taking p equal to 17 and g equal to 3. Then already in these steps we have seen that in the second step all the users must have their own. That means they have to choose their private keys. So here we are having 3 users, n equal to 3, right? 3 users are there. So Alice is choosing the private key as 5, and Bob is choosing the private key as 7, and Carol is choosing the private key as 11. So already we have seen one condition in choosing the private key. So what is that condition? Always these private keys must be less than the primitive root g. So this condition we have to check. So before start solving the problem, you have to see whether what all the values given are correct or not, whether the conditions are satisfied or not, that you have to check. Suppose if one of the condition is not satisfied, means also you have to mention that so this particular condition is not satisfied. Say for example, suppose C is given as 21. In that case, what you have to tell? It is not less than G. Likewise, the justification is required. So first step over, second step over. Then moving on to the third step. Third step, you are aware that we are having 3 users, A, B and C we are having. So what we have to do? A has to compute one value and send to B, and B had to compute one value and send to C. So finally C is having that shared secret key. Likewise, the same procedure is followed by everyone. B has to compute with his private key and send that value to Carol, and Carol has to compute something with with her own private key and send to Alice. Finally, Alice having. Likewise, the steps are followed. So all of you are aware. Here only 3 users, so only 11 steps are there. So first we will start from the third step onwards. So in third step, what Alice is doing? Alice has to compute g power a mod p. So what is g? All the values we know. Here whatever the parameters there, variables there, we know all the values. So g is 3 power a is 5. So 3 power 5 mod 17. So this only we have to calculate. So 3 power 5 is a very simple small value only, a small power only. So we can easily calculate that value using calculator. Suppose if you are having a higher power value, so 3 power 55, in that case how to compute that value? That is very required here in cryptography. You need the higher powers, how to solve in a very simplified manner. So for that we are having one method, that is a square and multiply method is there. So you can use that square and multiply method also. So here it is not required but for small value I am telling how to use that value. So here suppose higher powers are there, means also you can utilize this method to solve that. Because sometimes what happens means, if you are using higher powers, in the calculator itself it is given e something, some value is given. So in that case, some manual computation is very difficult. So using the square and multiply method, each and every step we are minimizing the value. so that it is very easy to compute. So how to compute this value means, here we are having 3 power 5. So the power, one number is there in the power, right? Here 5 is in the power. So that value you have to compute to binary. So 5, it is in the decimal, so that we have to compare, that is base 10, right? 5 is base 10, so you have to convert that to base 2 format. So in base 2 format, binary format, what you have to do is, it is 101, that only 5 value you are aware. So for the first one, you have to take this base value alone, you have to consider. So here it is 3 only. Then from second value onwards, suppose if you are having 0 digit, only it is binary means 2 digits are there, 0 and 1 is there. Suppose if you are getting 0, in that case what you have to do, you have to perform only square operation, you have to perform. Square alone you have to perform. 1 is there means you have to perform square and multiply operation, you have to perform. So here 0, so you have to perform square, that is 3 into 3. It is 9. 9 mod 17 is 9 only, so no problem. Here also 3 mod 17, 3 only. Here 9 mod 17, 9 only, so no problem in that. Then next value is 1. So for 1, what you have to do, you have to perform square and then multiply. So what square you have to do, it is 9 into 9 you have to perform. So that is 81 mod 17. So what is 81 mod 17? It is 13. That is small value only, you can easily calculate. Then now square is over, 13 is the value. Then you have to multiply. So with what value you have to multiply? The base value only you have to multiply. So 13 into 3 you have to compute. So 13 into 3, that is 13 into 3 equal to 39 mod 17. So what is 39 mod 17? It is 5. So the value is 5. So 3 power 5 mod 17 is 5. This value is 5. So likewise we have to compute. Then after computing this value, what Alice is doing? Alice is sending this value to Bob. So Bob, what Bob is doing? Bob now knows 3 power 5 mod 17 value Bob received. So Bob is having his own private key, right? So 3 power 5 into 7 mod 17 has to be computed by Bob, and this value has to be sent to Carol. Then Carol, what Carol do? 3 power 5. Then Carol is having 11. So this value, that is 3 power 5 into 7 into 11 mod 17. So this value Carol has to compute. So in all these steps, you have to minimize the value, then you have to perform all the computation. So now Carol is having one value. That value only we are calling it as the shared secret key. Let us see what are the values they obtained. So here these values are, so Alice computed g power a mod p, that is 5, and send this value to Bob. Then Bob computes g power a b mod p, that is g power a b mod p. It is 10. You try to calculate the same procedure only we are following. Then Carol computes g power a b c mod p, that is g power a, it is 3. So this 3 is the shared secret key. So now itself we know what is the value. But anyway, we have to perform these steps also. Other steps also we have to perform, and finally we have to conclude that. So the shared secret key is 3. So here you see Bob computes g power b mod 11 and sending it to Carol. Then Carol is computing the value g power bc mod p and sending it to Alice. Then Alice is computing g power abc mod p. So now also we are getting a 3 value. Likewise, then Carol computes. So likewise, if n users are there, now for 3 users we computed. Say for example, now another user, Darth is there. In that case, what we have to do? Alice to Bob, Bob to Carol, Carol to Darth. Then Bob to, the cycle goes on. So extra steps we have to perform. So finally, everyone, that is Carol is having the value 3. Then Alice is having the value 3 and Bob is also having the value 3. So this shared secret session key is 3 here. So here in the question, what you are asked to do, perform the multi-party Diffie-Hellman key exchange and compute the shared secret key. So this is the multi-party key exchange algorithm. So all these steps you have to perform, and finally you have to write the answer, what is the shared secret key. So I think it's very clear for everyone. And extra stuff we have seen is for higher powers how to compute the value using square and multiply method. So if here it is given as 3 users, if n users are given means also it's the same procedure only you have to follow. Thank you.